Gary,
then you
come on,
would find out
man.
Alright, so here we go. Today we're looking at average value. So remember, whenever you see that word value, you have to pay attention to what part? The Y, right? Always, okay? We don't want to mess up like we did on that quiz one time, remember? Where it asked for the maximum or minimum value and you guys were putting the X part rather than the Y part. So be careful on that, right? Now, what about the word average? What's another word for average? Mean, right? Calculus teachers are not mean, we're above average. I can't agree. I'm gonna wear that one on the AP test. Good? So they could also ask for the mean value, right? Oh, doesn't that kind of sound like the mean value theorem? Okay, there is also the mean value theorem for integrals, just like there's mean value theorem for derivatives, okay? Cool? Alright, but all you have to remember is that it's the average value, don't panic. Alright, so how do we find average velocity? Anybody remember? What we would do? We would have to remember that it would be the AROC of what? Of position, right? Okay. We had to remember that so we could write the formula, right? We would say that it would be P of B minus P of A over B minus A, yes? Okay. We have to imagine a secant line being drawn from the point, right, at A to the point at B, and then finding the slope of that secant line on that position graph, right? That would be the average velocity. Okay, how do we find average acceleration? AROC of velocity now, right? But it was called average acceleration. So now we would find V of B minus V of A over B minus A. Yes? It's the average rate of change of velocity. Now we're drawing a secant line on the velocity graph and finding the slope of that secant line. Super easy? Yes? This is the formula that we use to approximate instantaneous, right? Velocity and instantaneous acceleration if we don't have the given value, right? But we have stuff around it to be able to use. Alright. So let's say that P of t, V of t, and A of t represent position, velocity, and acceleration for any time t. They want you to write the equivalent expression for each of these, okay, based on the fundamental theorem of calculus. So according to FTC, when I integrate A of t, what should it give me? What's the antiderivative of acceleration? Velocity, right? And if I apply the fundamental theorem of calculus, it would say V of what? V of B minus V of A, right? But it has this 1 over B minus A in the front multiplied by it. So what would I have to do to that? Divide it by B minus A? Oh my god. That kind of looks like what we just did up here. So what could we say that this integral here is equivalent to? The average acceleration. So haven't you had some problems like that on your assignments where they give you something that looks like that? And they give you a fraction on the outside? Didn't it look like the one we just did over here? Where we had that 1 over 8, the integral from 0 to 8 of t of x dx? What did this represent? The average temperature, right? Average whatever I'm integrating, right? So this was average acceleration. Do we understand?
Yeah.
Where did they get the 8 from? 8 minus 0 is 8. Okay? But they didn't show that. There was one in another assignment where you had a 35 there, 1 over 35, right? And they got that 35, I told some of you that asked me, by doing the 60 minus the 25. That's how they got the 35. That problem actually represented the average acceleration. Alright, how about this one down here? What would this be? The average what?
Velocity.
this should be the average velocity. Let's see if it gives us that formula we got up there. Okay, so what's the antiderivative of velocity, Ricky?
The antiderivative velocity,
Yeah,
it's P.
position, right?
Yeah, position.
Position, thank you. So if we apply the fundamental theorem of calculus, what would we get here?
P of V.
P of B, good, minus P of A. And then all of that times 1 over B minus A, which just makes me divide it by B minus A. Was it the average velocity?
Yeah.
Awesome. Okay, so we gotta remember this formula because it will be helpful and it's something that we could use to find average anything. If they tell you to find the average temperature, boom, we can use this integral. Find the average amount of rainfall, boom, we can use this integral. Find the average amount of snow that is melting, boom, we can use this formula. Find the average amount of sand that was added to the beach, boom, we can use this formula. Find the average, I don't know, sand falling on the pile, boom, we can use this formula. Find the average number of clowns at the circus, boom, we can use this formula. You got it? Yes? Alright, so the average value of a function, whatever that function may be, whatever that function may represent, on a specific interval can be defined to be what? What do you think that average value formula is going to be? 1 over B minus A times the integral from A to B of f of x dx. Super easy? So if you notice a fraction in front of an integral like that, it may possibly be that you're finding average something. You just want to make sure that this number that they have down here, that they actually got it by subtracting the two limits that are there. Okay? If it is, then you know you're talking about average of whatever it is that that function represents in that time interval. Pretty simple? Okay? Now what does it actually mean and where does it actually come from and how does it apply here? Okay? What's actually happening, okay, is you're finding the average value. It says it's a y value slash a height, and we're calling that f of c, of a rectangle that has the same bounded space as the bounded space between the curve and the x-axis. So let's say I draw this curve and I tell you to find the bounded space from A to B. Okay? Well, we can find that space by trying to find a rectangle that has a particular height to where if I find the area of that rectangle, it'll actually equal the area under that curve. Okay, so do you notice that this missing space right here is the space that's above the rectangle up here? So it balances out. Okay? Now to find that value, we first need to find this C. And when I plug in that C, it'll give me the height, which is f of C. You understand? How do I find the area of a rectangle? Base times height, okay? So how would I calculate the base? How do I calculate this length here? Oh, okay, so B minus A, that's the base, times, what would the height be? F of C. Okay, so this is the rectangle, right? We said that that rectangle should equal to the integral, or the bounded space of the curve. So what would give me that formula? The integral from A to B of that function, right? Yes?
Yeah.
So this right here represents the space between the curve and the x-axis, right? How can I get this to be the same as that average value formula? Divide by b minus a, right? So if I divide by b minus a, that'll give me the 1 over b minus a times this integral, and it says that it's equal to what? F of c. So the average value will be represented by f of what? f of c. That average value is gonna be the height of that rectangle, okay? That you can use to be able to imagine a rectangle there and have the same area as the bounded area of the curve in the x-axis. Does that make sense? Okay, so there's gonna be problems where they ask you to find that average value, f of c, and there's gonna be problems where they ask you to find that c. Find that x value that when you plug into the function gives you this number. Gives you that average value. You understand? When I was creating your quizzes, some of you got to the point where you got this. F of k has to equal to 2, and then you told me, oh, k is 2. Is that correct? This does not imply that k is 2. This implies that the y value is 2 when k is some number, right? You needed to find that number that when I plug in there gives me 2. Some of you didn't do that. Some of you told me that you got to here and you just say, oh, k is 2. Okay, so you're misunderstanding that problem. Be careful, okay? Cool? Are we okay? Ready to do some examples? Seems easy? Alright, so we're going to be jumping back and forth with calculator and non-calculator problems to practice both. Okay, so this first one is non-calculator. What do they want us to find? Average value of this function.
Sorry for the interruption. So do you have Ariana Villalobos?
No. I think they got the wrong rules. I don't have a Villalobos here, right? Alright, so average value of the function. How do I find average value? That should be the key word. Boom. And you gotta remember the formula. What's it gonna be? Let's write down the formula. 1 over b minus a times the integral from a to b of f of x dx. So let's do it. What's a and b here?
2, 5, and 2.
So 1 over 5 minus 2, which we can do in our head and just put a 3 if we wanted to, times the integral from 2 to 5 of x squared plus 1 dx. And this is non-calculator, so we got to do it by hand. Okay? It's a little oil. So, focus. So we get 1/3 times, what's the antiderivative of this?
Mr. Science, do you have a master key
Yes?
for E223?
E223? All the way over there?
Just kidding, C.
I was like,
You're funny, you're funny.
you wanna go over there and bring it back? Thank you. I was like, E? I'm not gonna walk all the way over there. Alright, so what's the antiderivative of this guy? So 1 over 3 x cubed plus x evaluated from 2 to 5. I need to do this antiderivative and calculate this value, and then after I do that, multiply it by that 1/3. Okay? So what do we end up with there? Plug in the 5. 5 to the third.
125.
125 over 3 plus 5 minus, plug in the 2.
8 over 3.
8 over 3 plus 2. Alright. So let's subtract the fractions because they're both divided by 3. So 125 minus 8. 117 over 3. Subtract the other numbers. 5 minus 2. Plus 3. And then we have all of that times 1/3. Yeah? So I'm going to multiply by 1/3 so I can get this 3 to be a 1. That gives me 117 over 9 plus 1. Which we know 1 is the same thing as 9 over 9. 9 plus 117.
126.
126 over 9. And what does that equal?
Can you like that?
We don't wanna leave it like that, cause the problem also, thank you, asks us to do something else after that.
Oh, fine.
Said find the C after I find this average value.
Ooh.
But let's divide it, come on, you know how to divide.
Yeah, it's
How many nines into 12? 1, so 12 take away 9. 3, bring down the 6. How many nines into 36? 4. Alright, what is this answer? 14. Thank you, see that wasn't too hard. Okay. Non-calculated. Number sense. Good? This is the average what? Value. This is equal to f of c. So we're going to say c is 14?
new.
No. We want the number that when I put into the function gives me 14 as an answer. Okay? I don't have too much space here because I wrote too big. But hopefully we don't need that much. How are we going to find that c?
Equal it to x squared plus 4.
Very good. So equal it to the function, the original. So if I find f of c, I get c squared plus 1, right? And we know f of c is 14. So now we can work it there. So minus 1